Welcome back. It's Wednesday morning. Let's try read a bit more. Did read about Airbus 350 yesterday and made some video on my language Danish. So let's try read about Boeing at 777 777. And we have a new 777X later next year. I think I got it here. This one will read next. So later next year we have a new generation of this 777. But let's read this. But I need a minute. Need a minute to get to my bed. So, but that's a long one. It's a long read. So probably I need to stop after 1.5 hours and charging my camcorder.
Boeing 777, 777 and B777 redirect here. For the road in Scotland, see B777 road. For other uses, see 777, disambiguation. The Boeing 777, commonly referred to as the 777, is an American long-range wide-body airliner developed and manufactured by Boeing Commercial Airplanes. The 777 is the world's largest twinjet and the most built wide-body airliner. The jetliner was designed to bridge the gap between Boeing's other wide-body airplanes, the twin-engine 767 and quad-engine 747, and to replace aging DC-10 and L-1011 trijets. Developed in consultation with 8 major airlines, the 777 program was launched in October 1990, with an order from United Airlines. The prototype aircraft rolled out in April 1994, and first flew in June of that year. The 777 entered service with the launch operator United Airlines in June 1995. Longer-range variants were launched in 2000, and first delivered in 2004. The 777 can accommodate a 10 abreast seating layout and has a typical 3-class capacity of 301 to 368 passengers, with a range of 5,240 to 8,555 nautical miles, mi. 9,700 to 15,840 kilometers, 6,030 to 9,840 mi. The jetliner is recognizable for its large diameter turbofan engines, raked wingtips, 6 wheels on each main landing gear, fully circular fuselage cross-section, and a blade-shaped tail cone. The 777 became the first Boeing airliner to use fly-by-wire controls and to apply a carbon composite structure in the tailplanes. The original 777 with a maximum takeoff weight of 545,000,660,000 pound, 247,299 was produced in 2 fuselage lengths. The initial 777-200 was followed by the extended range -200 in 1997, and the 33.25 feet, 10.13 m, longer 777-300 in 1998. These have since been known as 777 Classics and were powered by 77,298,000 lbf, 343436 kN, General Electric GE90, Pratt & Whitney PW4000, or Rolls-Royce Trent 800 engines. The extended range 777-300 with a MTO of 700,000,775,000 pound, 318352T, entered service in 2004. The longer range 777-200LR in 2006, and the 777F freighter in 2009. These second-generation 777 variants have extended raked wingtips and are powered exclusively by 110,000,115,300 lbf, 489513 kN, GE90 engines. In November 2013, Boeing announced the development of the third-generation 777X. Variants include the 777-8, 777-9, and 777-8F, featuring composite wings with folding wingtips and General Electric GE9X engines, and slated for first deliveries in 2026. As of 2018, Emirates was the largest operator with a fleet of 163 aircraft. As of December 2024, more than 60 customers have placed orders for 2,303 777s across all variants, of which 1,741 have been delivered. This makes the 777 the best-selling wide-body airliner, while its best-selling variant is the 777-300 with 833 delivered. The airliner initially competed with the Airbus A340 and McDonnell Douglas MD-11. Since 2015 it has mainly competed with the Airbus A350. First-generation 777-200 variants are to be supplanted by Boeing's 787 Dreamliner. As of May 2024, the 777 has been involved in 31 aviation accidents and incidents, including 5 hull loss accidents out of 8 total hull losses with 542 fatalities including 3 ground casualties. Development, edit. Background, edit. In the early 1970s, the Boeing 747, McDonnell Douglas DC-10, and the Lockheed L-1011 TriStar became the first generation of wide-body passenger airliners to enter service. In 1978, Boeing unveiled 3 new models: the twin-engine or twin-jet Boeing 7N7, later named Boeing 757, to replace its 727, the twin-jet Boeing 7X7, later named 767, to challenge the Airbus A300, and a Tri-J 777 concept to compete with the DC-10 and L-1011. The mid-size 757 and 767 launched to market success, due in part to 1980's extended-range twin-engine operational performance standards, ETOPS, regulations governing transoceanic twin-jet operations. These regulations allowed twin-engine airliners to make ocean crossings at up to 3 hours distance from emergency diversionary airports. Under ETOPS rules, airlines began operating the 767 on long-distance overseas routes that did not require the capacity of larger airliners. The Tri-J 777 was later dropped, following marketing studies that favored the 757 and 767 variants. Boeing was left with a size and range gap in its product line between the 767-300 and the 747-400. By the late 1980s, DC-10 and L-1011 models were expected to be retired in the next decade, prompting manufacturers to develop replacement designs. McDonnell Douglas was working on the MD-11, a stretched successor of the DC-10, while Airbus was developing its A330 and A340 series. In 1986, Boeing unveiled proposals for an enlarged 767, tentatively named 767X, to target the replacement market for first-generation widebodies such as the DC-10, and to complement existing 767 and 747 models in the company lineup. The initial proposal featured a longer fuselage and larger wings than the existing 767, along with winglets. Later plans expanded the fuselage cross-section but retained the existing 767 flight deck, nose, and other elements. However, airline customers were uninterested in the 767X proposals, and instead wanted an even wider fuselage cross-section, fully flexible interior configurations, short to intercontinental range capability, and an operating cost lower than that of any 767 stretch. Airline planners' requirements for larger aircraft had become increasingly specific, adding to the heightened competition among aircraft manufacturers. By 1988, Boeing realized that the only answer was a clean sheet design, which became the Twinjet 777. The company opted for the twin-engine configuration given past design successes, projected engine developments, and reduced cost benefits. On the 8th of December, 1989, Boeing began issuing offers to airlines for the 777. Design effort, edit. Alan Muellerly served as the Boeing 777 program's Director of Engineering, and then was promoted in September 1992 to lead it as Vice President and General Manager. The design phase of the all-new Twinjet was different from Boeing's previous jetliners. 8 major airlines, All Nippon Airways, American Airlines, British Airways, Cathay Pacific, Delta Airlines, Japan Airlines, Qantas, and United Airlines, played a role in the 777 development. This was a departure from industry practice, where manufacturers typically designed aircraft with minimal customer input. The 8 airlines that contributed to the design process became known within Boeing as the Working Together Group. At the group's first meeting in January 1990, a 23-page questionnaire was distributed to the airlines, asking what each wanted in the design. By March 1990, the group had decided upon a baseline configuration, a cabin cross-section close to the 747's, capacity up to 325 passengers, flexible interiors, a glass cockpit, fly-by-wire controls, and 10% better seat mile costs than the Airbus A330 and McDonnell Douglas MD-11. The development phase of the 777 coincided with United Airlines' replacement program for its aging DC-10s. On the 14th of October, 1990, United became the launch customer with an order for 34 Pratt & Whitney-powered 777s valued at $11 billion, $22.7 billion in 2023, and options for 34 more. The airline required that the new aircraft be capable of flying 3 different routes, Chicago to Hawaii, Chicago to Europe, and non-stop from Denver, a hot and high airport, to Hawaii. ETOPS certification was also a priority for United, given the overwater portion of United's Hawaii routes. In late 1991, Boeing selected its Everett factory in Washington, home of 747 and 787 production, as the 777's final assembly line, FAL. In January 1993, a team of United developers joined other airline teams and Boeing designers at the Everett factory. The 240 design teams, with up to 40 members each, addressed almost 1,500 design issues with individual aircraft components. The fuselage diameter was increased to suit Cathay Pacific. The baseline model grew longer for all Nippon Airways, and British Airways input led to added built-in testing and interior flexibility, along with higher operating weight options. The 777 was the first commercial aircraft to be developed using an entirely computer-aided design, CAD, process. Each design drawing was created on a three-dimensional CAD software system known as CATIA, sourced from Dassault Systems and IBM. This allowed engineers to virtually assemble the 777 aircraft on a computer system to check for interference and verify that the thousands of parts fit properly before the actual assembly process, thus reducing costly rework. Boeing developed its high-performance visualization system, Fly-Through, later called IVT, Integrated Visualization Tool, to support large-scale collaborative engineering design reviews, production illustrations, and other uses of the CAD data outside of engineering. Boeing was initially not convinced of CATIA's abilities and built a physical mock-up of the nose section to verify its results. The test was so successful that additional mock-ups were cancelled. The 777 was completed with such precision that it was the first Boeing jetliner that did not require the details to be worked out on an expensive physical aircraft mock-up. This helped the design program to limit costs to a reported $5 billion. Testing and certification, edit. Major assembly of the first aircraft began on the 4th of January, 1993. On the 9th of April, 1994, the first 777, number WA001, was rolled out in a series of 15 ceremonies held during the day to accommodate the 100,000 invited guests. The first flight took place on the 12th of June, 1994, under the command of Chief Test Pilot John E. Cashman. This marked the start of an 11-month flight test program that was more extensive than testing for any previous Boeing model. 9 aircraft fitted with General Electric, Pratt & Whitney, and Rolls-Royce engines were flight tested at locations ranging from the desert airfield at Edwards Air Force Base in California to frigid conditions in Alaska, mainly Fairbanks International Airport. To satisfy TOPS requirements, 8 180-minute single-engine test flights were performed. The first aircraft built was used by Boeing's non-disruptive testing campaign from 1994 to 1996, and provided data for the -200 and -300 programs. At the successful conclusion of flight testing, the 777 was awarded simultaneous airworthiness certification by the U.S. Federal Aviation Administration, FAA, and European Joint Aviation Authorities, JAA, on the 19th of April, 1995. Entry into service, edit. Boeing delivered the first 777 to United Airlines on the 15th of May, 1995. The FAA awarded 180-minute ETOPS clearance, ETOPS 180, for the Pratt & Whitney PW4084 engined aircraft on the 30th of May, 1995, making it the first airliner to carry an ETOPS 180 rating at its entry into service. The first commercial flight took place on the 7th of June, 1995. From London Heathrow Airport to Dulles International Airport near Washington, D.C. Longer ETOPS clearance of 207 minutes was approved in October 1996. On the 12th of November 1995, Boeing delivered the first model with General Electric GE90-77B engines to British Airways, which entered service 5 days later. Initial service was affected by gearbox bearing wear issues, which caused British Airways to temporarily withdraw its 777 fleet from transatlantic service in 1997, returning to full service later that year. General Electric subsequently announced engine upgrades. The first Rolls-Royce Trent 877-powered aircraft was delivered to Thai Airways International on the 31st of March, 1996, completing the introduction of the three power plants initially developed for the airliner. Each engine aircraft combination had secured a TOPS 180 certification from its entry into service. By June 1997, orders for the 777 numbered 323 from 25 airlines, including launch customers that had ordered additional aircraft. Operations performance data established the consistent capabilities of the twinjet over long-haul transoceanic routes, leading to additional sales. By 1998, the 777 fleet had approached 900,000 flight hours. Boeing states that the 777 fleet has a dispatch reliability rate of departure from the gate with no more than 15 minutes delay due to technical issues, above 99%. Improvement and stretching, -200//300, edit. After the baseline model, the 777-200, Boeing developed an increased gross weight variant with greater range and payload capability. Initially named 777-200 IGW, the 777-200 first flew on the 7th of October, 1996. Received FAA and JAA certification on the 17th of January, 1997, and entered service with British Airways on the 9th of February, 1997. Offering greater long-haul performance, the variant became the most widely ordered version of the aircraft through the early 2000s. On the 2nd of April, 1997, a Malaysia Airlines -200 named Super Ranger broke the Great Circle distance without landing record for an airliner by flying eastward from Boeing Field, Seattle to Kuala Lumpur, a distance of 10,823 nautical miles, 20,044 kilometers, 12,455 mi, in 21 hours and 23 minutes. Following the introduction of the -200, Boeing turned its attention to a stretched version of the baseline model. On the 16th of October, 1997, the 777-300 made its first flight. At 242.4 feet, 73.9 m, in length, the -300 became the longest airliner yet produced, until the A340-600, and had a 20% greater overall capacity than the standard length model. The -300 was awarded type certification simultaneously from the FAA and JAA on the 4th of May, 1998, and entered service with launch customer Cathay Pacific on the 27th of May, 1998. The first generation of Boeing 777 models, the -200, -200, and -300 have since been known collectively as the Boeing 777 Classics. These three early 777 variants had three engine options ranging from 77,200 to 98,000 lbf, 343 to 436 kN. General Electric GE90, Pratt & Whitney PW4000, or Rolls-Royce Trent 800. Production, edit. The production process included substantial international content, an unprecedented level of global subcontracting for a Boeing jetliner, later exceeded by the 787. International contributors included Mitsubishi Heavy Industries and Kawasaki Heavy Industries, Fuselage Panels, Fuji Heavy Industries, Limited, Center Wing Section, Hawker de Havilland, Elevators, and Aerospace Technologies of Australia, RUDA. An agreement between Boeing and the Japan Aircraft Development Corporation, representing Japanese aerospace contractors, made the latter risk-sharing partners for 20% of the entire development program. To accommodate production of its new airliner, Boeing doubled the size of the Everett factory at the cost of nearly $1.5 billion, $2.86 billion in 2023, to provide space for 2 new assembly lines. New production methods were developed, including a turn machine that could rotate fuselage sub-assemblies 180 degrees, giving workers access to upper body sections. By the start of production in 1993, the program had amassed 118 firm orders, with options for 95 more from 10 airlines. Total investment in the program was estimated at over $4 billion from Boeing, with an additional $2 billion from suppliers. Initially second to the 747 as Boeing's most profitable jetliner, the 777 became the company's most lucrative model in the 2000s. An analyst established the 777 program, assuming Boeing has fully recouped the plane's development costs, may account for $400 million of the company's pre-tax earnings in 2000, $50 million more than the 747. By 2004, the airliner accounted for the bulk of wide-body revenues for Boeing commercial airplanes. In 2007, orders for second-generation 777 models approached 350 aircraft, and in November of that year, Boeing announced that all production slots were sold out to 2012. The program backlog of 356 orders was valued at $95 billion at list prices in 2008. In 2010, Boeing announced plans to increase production from 5 aircraft per month to 7 aircraft per month by mid-2011, and 8.3 per month by early 2013. In November 2011, assembly of the 1,000TH777, A-300A, began when it took 49 days to fully assemble one of these variants. The aircraft in question was built for Emirates Airline, and rolled out of the production facility in March 2012. By the mid-2010s, the 777 had become prevalent on the longest flights internationally and had become the most widely used airliner for trans-Pacific routes, with variants of the type operating over half of all scheduled flights and with the majority of trans-Pacific carriers. By April 2014, with cumulative sales surpassing those of the 747, the 777 became the best-selling wide-body airliner. At existing production rates, the aircraft was on track to become the most delivered wide-body airliner by mid-2016. By February 2015, the backlog of undelivered 777s totaled 278 aircraft, equivalent to nearly 3 years at the then production rate of 8.3 aircraft per month, causing Boeing to ponder the 2018-2020 time frame. In January 2016, Boeing confirmed plans to reduce the production rate of the 777 family from 8.3 per month to 7 per month in 2017 to help close the production gap between the 777 and 777X due to a lack of new orders. In August 2017, Boeing was scheduled to drop 777 production again to 5 per month. In 2018, assembling test 777 to 9 aircraft was expected to lower output to an effective rate of 5.5 per month. In March 2018, as previously predicted, the 777 overtook the 747 as the world's most produced wide-body aircraft. Due to the impact of the COVID-19 pandemic on aviation, demand for new jets fell in 2020 and Boeing further reduced monthly 777 production from 5 to 2 aircraft. Second generation 777X-300-200LR/F, edit. From the program's start, Boeing had considered building ultra-long-range variants. Early plans centered on a 777-100X proposal, a shortened variant of the -2